But give me meters. I don't really know how long now.
Hello guys, we are back with another video. Please subscribe our channel and press the bell icon to remain updated. Also follow us on Instagram, TikTok and Facebook. Please subscribe us so we grow together. Today's topic is glycolysis. Glycolysis is a process in which we convert glucose into two pyruvate molecules and also get some energy molecules in the form of ATP. This process happens in the cytoplasm. In this process, we invest some ATP and at the end we gain some ATP. So it is like a give and take process. We also get another energy molecule from it that is called NADH. So we get ATP and NADH from it. Let's discuss some physiology here. Let's assume that in the lunch you had a big slice of pizza. That means the glucose level in your body will be high. From the small intestine, the glucose will go to the bloodstream. And due to its high concentration, the beta cells of the pancreas will release insulin. Insulin plays a major role in maintenance of glucose in the body. Let's see what insulin does. Here we can see that there is more number of glucose in our bloodstream, and the bloodstream have cells around it which have a gate or pump which is called glucose transporter or GLUT. The insulin will initiate or start this pump from where the glucose molecule will transfer inside the cell. After glucose comes inside the cells, glycolysis process starts. First, glucose is converted into glucose 6-phosphate by some kinases present in it called glucokinase and hexokinase. Now let's see how this happens. When the glucose comes inside the cells, the kinase, hexo and glucokinase convert it to glucose 6-phosphate by adding additional phosphate in it. This reaction is irreversible. And this happens so glucose do not move outside of the cell again to the bloodstream. Hexokinase is present in all cells, but the glucokinase is only present in liver and pancreas. So hexokinase can convert glucose into glucose 6-phosphate in all cells. Now let's see the 10th step of glycolysis. The process starts from glucose, in which enzyme hexokinase and the consumption of ATP will convert glucose into glucose 6-phosphate. Here it is the first step where ATP is used and it is irreversible step. Then glucose 6-phosphate is converted by enzyme phosphoglucoisomerase, which will convert it to fructose 6-phosphate. Then fructose 6-phosphate will be converted with the help of the enzyme phosphofructokinase, and ATP is again utilized in it. Second ATP is invested in glycolysis and it will be converted into fructose 1,6-bisphosphate. Fructose 1,6-bisphosphate is the rate limiting step of glycolysis, and rate limiting step is also called the longest step of glycolysis. Let's see how it is the longest step of glycolysis. Fructose 6-phosphate is converted into fructose 1,6-bisphosphate by the enzyme phosphofructokinase, which is PFK1. But it not starts here. The fructose 6-phosphate is also converted into fructose 2,6-bisphosphate by the enzyme called PFK2. This reaction is initiated by insulin when the glucose level increases. With more production of fructose 2,6-bisphosphate, it will stimulate more production of fructose 1,6-bisphosphate. When the level of glucose will decrease in the body, glucagon is released by the body against insulin to inhibit this process. So this was the rate limiting step of the glycolysis, which is longest step. Then after fructose 1,6-bisphosphate, an enzyme called aldolase convert it to two molecules. The first one is glyceraldehyde 3-phosphate and the second one is dihydroacetone phosphate. Here the twist is that dihydroacetone phosphate can also can be converted into glyceraldehyde 3-phosphate by adding a enzyme called isomerase, which will lead to formation of two pyruvate molecules at the end. So now we have two molecules of glyceraldehyde 3-phosphate. Now it's a time to get some energy. We will get two NADH molecules because now we have two glyceraldehyde 3-phosphate with the enzyme called glyceraldehyde 3-phosphate dehydrogenase, which will convert it to 1,3-bisphosphoglycerate. Two molecules of 1,3-bisphosphoglycerate will be converted into 3-phosphoglycerate by an enzyme called phosphoglycerate kinase, which will give us a 2 ATP molecules. Now as you can see, we have used 2 ATP already before. Now by adding 2 ATPs, the count will be 0. We have gained 1 but we have lost. Now let's see what happens next. After 3-phosphoglycerate, it converts into 2-phosphoglycerate by the enzyme called mutase. We will get two molecules of each. After it, 2-phosphoglycerate two molecules will be converted to two molecules of phosphoanilopyruvate which from the enzyme called endolase. The last step is irreversible, which will give us two more molecules of ATP and we will get pyruvate by the enzyme called pyruvate kinase. And at the end we will get 2 ATP produced from glycolysis. So let's see how many ATP we consume and how many we got. ATP consumed on the first step, 1 ATP consumed in the third step, so 2 ATP are consumed. At 6th step we got 2 NADH molecules, 7th step we got 2 ATP molecules, and at the 10th step we got 2 ATP molecules. So at the end we got 2 ATP molecule produced in glycolysis. It's not a big number, but from the energy molecules it take part in other processes like fatty acid oxidation and Krebs cycle and makes up to 30 to 32 ATPs at last. So thank you for watching the video. If you have any queries, watch again and also comment that how was the video. Please subscribe our channel. I need your support so we can grow together. If you have any queries, there is a comment section. You can go and ask question.
But give me reading.